Okay, quadrilateral family tree. You should have drawn a quadrilateral at the top. Notice that this is just a random four-sided shape. So quadrilateral, by definition, is any shape with four sides. Okay, and then quadrilateral had a baby named Parallelogram. And this is what we focused on last week. And then tomorrow we're going to add two more babies from quadrilateral, but for now we're just going to focus on parallelogram and then parallelogram's babies. First of all, what we learned about parallelogram is a parallelogram, by definition, the opposite sides are parallel. So that means that this side is parallel to this one, and this side is parallel to this one. We also learned that in a parallelogram, the opposite angles are equal, so this angle is the same measure as this one, and this angle is the same measure as this one. And then additionally, opposite sides are congruent. So this side is the same length as this side, and this side is the same length as this one. And we're going to draw one more just so that everything's in one spot. Okay, here's our parallelogram. And we learned that the diagonals bisect each other. So here's a diagonal, and here's a diagonal. Where these intersect is like each of their midpoints. So this is the same measure as this, and this here is the same measure as this. So just making a little note, diagonals bisect each other. Okay, so now we're going to break into what we're focusing on today. We're focusing on rectangles, rhombuses, rhombi, and squares. So parallelogram has two babies. One is called a rectangle, and the other baby is called a rhombus. We're going to focus on rectangle first just because, I don't know, it's just more familiar. Okay, so what makes a rectangle is it follows all of this. It's actually a parallelogram, but in addition to all of these properties, it also has four 90-degree angles. So here's a rectangle, and a rectangle has four right angles. Four right angles. But just like its parent, the opposite sides are also parallel, opposite sides are congruent, and the diagonals bisect each other. But there's one more thing about the diagonals in a rectangle. So I'm just going to draw out another rectangle. So let's call this rectangle A, B, C, D. And let's say I have a diagonal here and a diagonal here. For this, the diagonals are now, not only do they bisect each other, but they're also congruent. So diagonals are congruent. So AC is the same length as BD. So since the diagonals are congruent and they bisect each other, then this would be equal to this, and since this whole thing is equal to this whole thing, this is also equal to this. So essentially all these segments are the same measure. And then taking it one step further, which will come up in today's lesson, the angles, since these are all now isosceles triangles, this angle is going to be equal to this one. Jumping a little bit, but I think you can handle it. So this angle would be equal to this one. and so on and so forth. This angle would be equal to this one because they're all isosceles triangles, and based on the isosceles triangle theorem, the angles opposite those congruent sides are going to be equal as well. Okay, that's rectangle. Now we're going to focus on a rhombus. So moving over here, the other sibling, a rhombus. A rhombus is a parallelogram. It has 4 congruent sides. So I'm trying to make this as kind of equal as possible. I'm not perfect, but okay. There's a rhombus. These sides should all be the same length. Again, I'm not perfect. Yours might not be perfect either, but we'll try. All sides are congruent. And again, it's a parallelogram, so opposite sides are parallel, opposite sides are equal, diagonals bisect each other, and then in addition to that, drawing another rhombus as best I can. The diagonals are actually perpendicular, so if I draw a diagonal here and one here, it should make a 90-degree angle. Diagonals are perpendicular. I'm drawing one more rhombus. There's one more thing I want to show you. Okay, another rhombus. The other thing that happens with a rhombus is the diagonals actually bisect the angles. So this diagonal right here bisects this angle, so this side is the same measure as this one. This side is the same measure as this one. Diagonals bisect the angles. Bisect the angles. It's supposed to say bisect. Okay, so I also said that we were going to go over square. And where does square fit into all this? What's that? Oh, did you have a question? Oh, square, let's say rectangle and rhombus had a baby. You're not supposed to do that. Siblings shouldn't have babies. But in this case, they are. And rectangle and rhombus had a baby square. So a square has literally all of the properties of a parallelogram, rhombus, rectangle, and everything to make a square. So a square, drawing it out, as you know, all the sides are equal like a rhombus, but it also has the 90-degree angles like a rectangle, and there is your square. So a square, of course, the diagonals would bisect each other and be equal, and everything's perfect in a square. Okay. That's our quadrilateral family tree. Keep this out because we're going to use this as we do the workbook pages, and our calculations and everything will kind of come from this. So, I'm going to end the video.